Okay, this will be the third part of the hot air engine build. Oh my goodness, what happened? Because it plunged that 1/4-inch end mill. Seemed to be kind of noisy there. Startled me. Okay, anyway, this will be the start. We're going to make the end cap for the hot air chamber. So we're gonna cut that out with CNC. That's what we're gonna do, and we're gonna braze it to the chamber. The chamber's built. I did it off camera, I guess, the second part of it. So the chamber is ready to go, and we're ready for an end cap. So we're gonna cut this out with CNC, and right now we're cutting the pocket. The pocket is about 1 millimeter deep or 40 thousandths of an inch deep. So we got a 1/4-inch end mill, 4-flute end mill running at 2,500 RPM. And we can run it faster, I think. I'm only running it at 8 inches per minute, but I think we can run it up to 16 if we want. So I can manually do that if I decide that everything's going smoothly. So let me zoom in just a little bit, and we'll see where we're at here. We just got a piece of plate there. I don't know what gauge that is, about 100,006. So this cap needs to be about 80,000. So when we finish cutting out the cap, it'll be 20 thousandths too thick, which that probably doesn't matter in reality, but I think, here we go, making noisy again. So I'll just let it run. I don't have anything else to tell you. This takes about 25 minutes if I don't speed it up, and I'll fast forward through it. So when I edit the video, so we won't be waiting 25 minutes for it to happen. And let's see, what else can I talk about while this is cutting here, so save some time. If I zoom out, I guess, I'll sit them right here on the edge. So we have the hot air chamber, and we're also ready to make end caps for the displacer. So they're not sitting level there because, as you can see, that's what I did the hot air chamber off camera. Those larger sections are about 10 thousandths of an inch thick, so they're pretty thin, and the displacer is very thin. It weighs like less than a feather. So anyway, so I got that out of the way. So I'll just let this thing run, and the compressor will be coming on and off because I'm blowing some air on there to clear the chip. Okay, I got the air off, get that out of the way. I'll zoom the camera out a little bit. We're well through there. I'm just going to zoom the camera out a little bit, get some of this stuff out of my way. Maybe we can move the Z-axis up. I'm getting chips in my tools here. Okay, there we go. Get some of this swarf off here. That'll clean up. It looks kind of rough right now, but it's going to clean up. I'll put it in the lathe and I'm put it in the lathe and take 20 thousandths off the back side of it. Let's see if I can get some way to get that off there. Yeah, this one's a tough one. There we go. There we go. Well, there's what it came out of. Well, there's that. So we can get this end cap off here. Get some edge we can get under it here. There we go. Okay, there should be. It's got a 40 thousandths recess in it. This should fit hopefully over the end of the air chamber and the hot air chamber. And then on the back side, I need to make it a little thinner. Probably not really necessary, but the plan calls for it to be 2 millimeters thick. So I'm going to follow the plan. Let me go get the hot air chamber and see if it fits. I only allowed a little bit, so I might have to do some work. Oh, look at that. It's perfect. Absolutely perfect. So, couldn't ask for anything better. That'll silver solder up or braze. That'll work beautifully. So, great. That was the easiest way to do it. I thought about doing it on the lathe, but to me, this is the easiest thing to do, and it fits absolutely perfect. So there we go. So I'll end this video at this point, or at least this segment of it. We'll see how long it is. Maybe we'll add some more onto the end. So I'll be back. Okay, we're going to cut the one of the displacer end caps. We're going to cut it out of a piece of aluminum. We're going to use CNC to do that. Again, this piece of aluminum is 1/8 of an inch thick. It's about 130 thousandths. it needs to be 80. So in this case, we have no problem surfacing it down after we finished making the initial cut and making the end cap itself. We can just turn it over and put it back on the mill and use CNC to surface it down. So that's what we intend to do. I wrote a little software this morning in 5 minutes, and we've got a 3/16 4 flute end mill in there, and we're going to run this thing at about I don't know, 8 or 10 inches per minute, and I think we can run it up to 16. And so here we go. I'm going to turn on the mill. We're running at 2,500 RPMs, which is the maximum. We're going to put the air on so we can blow the chips away. And I've got somewhere around here, I got some WD-40 I can use for a lubricant. And hopefully, if we'll fast forward through this, I can splice it on to the last the video. So here we go. We're running at 10 IPM right now. Looks like it's going to run at that, no problem. So we'll leave it there. I don't think we need any coolant on it right now. I'm always concerned with these 4 flute end mills, but it's pretty sturdy end mill, 3/16 diameter, so I think we're good. Aluminum soft, you know, so. And we're cutting the inner circle first. It goes down 40 thousandths, and then we'll cut the outer circle next, and that'll cut it out actually. So we'll have a little 40 thousandths by 40 thousandths or 40 thousandths by something offset in the edge of it, where it'll create a lip where it sits inside the displacer tube. So hopefully I figured this out right. So I'll just let this run, and from this point we'll fast forward through it when I edit the video. there we go. It'd be nice if I had the correct thickness of aluminum, but I don't, so 1/8 of an inch is the smallest I've got. Actually, we need something like about 3/32. And we didn't use any coolant on that, so gets rid of some of the chips. There's the end cap. Might be a little trouble getting it off there. Always there. No, this one's coming off pretty easy. Well, there's. Let me turn the camera around. I can't see what I'm doing. Well, there's what it came out of right there. Piece of 1/8 inch, or actually it's 130 thousandths thick. I checked it. And then we've got. Let's see if we can get this off here. There we go. Now I can make this do a little better on the cut. Although in this case, probably doesn't matter too much. So there it is. You can see it's a little rough right now, but it'll clean up. You can see the little offset in it, and hopefully it fits onto the ID of the displacer. We'll see if it does. I measured the displacer outside diameter, and I left 2/1000ths of an inch for clearance is what I left. So we'll see. If it doesn't, then we'll have to improvise a little bit. Well, I'm going to go get the displacer and we'll see if it fits on there. So let's zoom out a little bit. Well, there it is. It does fit on there. Oh, dropped it. Shoot. I could have, it fits right in there. No problem. Actually, it fits in there. Actually, it fits in there nicely. Actually, I thought it was a little bit loose, but I guess I didn't push it all the way in. So it's on there. The outside diameter looks to be correct. I can clean that up, and you're not going to see much of that because if I take, let's say, I think it's almost 50 thousandths off this back side. Then this is going to be pretty thin, and this is all going to get. I think you're going to use 609, the green Loctite, to put that in place. That's my thinking. So that's it. So we got one. We have one more end cap to make for the displacer. It is a little more complicated because it has a threaded center in it where the push rod threads in, and also it has some relief on the back side that reduces its. You can make it thicker, but the weight is reduced by putting some relief on the back side. So anyway, it's a little more complicated, but we can do that on CNC too. Make the whole thing, and we'll have to do the threaded center, which has to be absolutely perfect on the lathe, you know. So we'll call off now, and I'll splice this onto the other video for the end cap on the air chamber, and the other end cap for the displacer we're going to do you know, off camera. So that gives you an idea, and very simple deal. So that took, I think I looked at the clock here. Oh, I see. Okay, the program ran for 12 minutes. So that was 12 minutes out of my life to make that end cap. So, piece of cake. Okay, thanks for watching. Talk to you later. Bye.